Okay, so hi everyone. Thank you for having me in that fabulous city of Dublin. Really happy to be there. And today I will try to make it quick because I only have 10 minutes anyway. And yeah, and we'll be talking about an experiment I did on how we could bring RT-Flow offloads to Virtio. But first, I'm Christophe Fontaine. I'm part of Red Hat for 5 years now. I'm mainly focused on OpenStack and heavy integration, but I'm also playing with Kubernetes and containers. But why? As David just explained to you, the transition from 10 gig interfaces to 25 and more, that's already done. All of those servers already are being shipped with 25 gig interfaces, if not more. And how does that translate for the hardware resources? From a deep tech perspective, from a specific workload from 10 gig to 25 gig, the transition is fairly simple. We just increase the allocated resource by 2.5 times. But really, on the virtual switch, do we really want today to allocate from 10 to 10 cores only for the virtual infrastructure? This also has additional implication, because when you had only a couple of cores dedicated to forwarding the packets from the physical interface to the virtual interfaces, multi-queue was not necessary. But with 10 of those threads, this becomes completely mandatory. And then you have to handle the multi-queue aspect on the virtual switch, on the RSS, as well as in your own application. And generally speaking, as we are increasing the number of resources and the amount of CPU cores for the virtual switch, this could increase this total cost of ownership. Because back in the days, we only had 22 cores, roughly, per socket. Now we may have up to 64. And so we're still consuming 15% of those CPU resources only for the virtual switch. And that's an existing concern about power management and so on and so forth. How to offload, that's a fabulous tool. Unfortunately, that's still only to offload your virtual switch or your virtual router. But what about your application? What if we want to optimize that part of the application? Before Red Hat, I was working for a DPI company, and roughly 90% of the traffic was just, we need to forward that packet, nothing more. Only 10% of those packets had to be actually analyzed by the application. If we're looking at firewall, why bother dropping the packet at the application level when you can do that at the virtual switch level? If we want to think about the general use case, think about DDoS mitigation. We are actually pushing with BGP flow spec that mitigation up to the router level. So what if we want to do the same, but from an application down to the virtual switch? Well, honestly, on the concept, that's easy, because from the application side, you just have to push the flow matches and action down to the virtual switch. And of course, on the other side, you may want to collect statistics. That way, you only process the targeted traffic, only the start of the connection, and so on and so forth. Very, very similar to what we can do today with RT-Flow offload. So I did a quick hack on the VS user messages and the performances. So modified the VS user protocol, added a couple of messages just to have those CRUD flow create updates destroyed, and then to collect the statistics, so that either with a control queue or through the VS user message from the driver on the Virtio side, we can send a specific message, an offload message, to the VS library. How does it translate in the real application? We do have two test PMD back-to-back with a VS user, and test PMD as a virtual switch, and the traffic generator. Without offload, with only one core, we are roughly in the 4 million packets per second ballpark. So that's really expected, but we're still consuming one full CPU core on the virtual switch and one full CPU core on the application itself. As soon as we enable that offload, because we're not forwarding packets into the Virtio virtual queues, Everything is great, we're completely line rate, and we're back to physical performances. And that's awesome, because we're not even consuming any CPU cycle on the application side. Then, David talked about the number of flows per second. How many flows can we inject that way through this Vios user message? So the time it takes to send a Vios user message from the application to the virtual switch back and forth with the acknowledgement back, that's roughly 50 microseconds in a container world. And that's up to 20,000 flows per second, which for some use cases would be great, and for many telco use cases are not enough. What if we add the QEMU and a virtualization layer in that process? As you can see, the software stack is slightly different, because that time we have to go through QEMU to forward those packets, or to forward those Vios flow updates, sorry. So we do get on the single flow exactly the same throughput and packet per second. That's the good news. So from the PPS and the throughput, we go from 4 million packets per second to 20 million, and the app is still idling. That's great. Yet, the time, because of that virtualization layer, or because of QEMU, and so on and so forth, and also because we don't have dedicated resources on QEMU, it takes up, well, minimum 800 microseconds. What does that mean? That means that we can only update 1,200 flows per second. So, and definitely that's way too low. On the security aspect as well, because we are actually injecting, modifying the pipeline and on the virtual switch, we could definitely have one pod stealing packets from another application. So from a security perspective, that's not good. Of course, that could be mitigated either with a mechanism to own a set of specific ports, which would add additional Virtio negotiation, so maybe not the proper way as of now, but an easier way would simply to have one dedicated bridge per pod or per virtual machine. At the end of the day, from OVS, if we want to talk about OVS, we only have one unique data path, whatever the number of bridges. So on the performance impact, there is no performance impact. But we do have that security constraint where one application can only act on its own port, thanks to that multi-layer bridge. So what would be the next step? Of course, I could go with that RFC and post that message, but only because of those flow updates per second performance, that's not enough, and I will not be posting that. It's available on the GitHub, of course, if you want to have a look, but it's not the proper RFC. What I wish to go forward is with an additional pair of virtual queue, because today we have that virtual queue pair. We have that virtual queue pair, which is dedicated for data for packets, but we could have exactly the same kind of virtual queue pair for those messages. So that's one way of doing things, and the other way would be to reuse that existing virtual queue pair to inject non-Ethernet and not traffic packets, but maybe not the proper way to do. Also, the other question is about how do we handle those messages in OVS, because we get those Vios user message and those flow updates from the libvios, but of course, how do we get that message and flow offload request back to the actual pipeline? So, thanks a lot.